A wall-mounted water fountain needs a ground fault circuit interrupter, GFCI. GFCIs are required for any electrical outlets located near water sources, as they provide protection against electrical shocks. In the case of a water fountain, the GFCI would be installed on the dedicated 20-amp, 120 volts receptacle servicing the fountain. An undersink pump for water drainage from a remote location does not typically require a GFCI. This is because the pump is usually located away from water sources and is not considered an electrical appliance in the same way as a water fountain. However, if the pump is located near water or could potentially come into contact with water, it may be prudent to install a GFCI for added safety. It's crucial to consult local electrical codes and regulations for definitive requirements, as these may vary depending on the specific location and application. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including GFCI protection. Here's a more detailed explanation of GFCI protection requirements. Firstly, consider the purpose of a GFCI. A GFCI is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing through a circuit. If it detects an imbalance, indicating that current is leaking to ground, it quickly trips the circuit, cutting off the power. This prevents electrical shock, which can be fatal. Secondly, the NEC mandates GFCI protection in specific locations where there is a higher risk of electric shock. These locations typically include bathrooms, kitchens, garages, outdoors, and near water sources. The rationale behind these requirements is that these areas are more likely to have wet conditions or contact with grounded objects, increasing the risk of electric shock. Thirdly, water fountains, due to their proximity to water, fall under the category of locations where GFCI protection is required. The water fountain itself presents a potential source of water spillage or splashing, and the electrical components of the fountain could potentially come into contact with this water. Therefore, to protect users from electrical shock, GFCI protection is essential. Fourthly, the dedicated 20-amp, 120 volts receptacle servicing the water fountain must be GFCI protected. This can be achieved in several ways, for example, by installing a GFCI receptacle directly in place of the existing receptacle, or by installing a GFCI circuit breaker in the electrical panel that feeds the circuit. In either case, the GFCI device will monitor the current flow into the water fountain and trip the circuit if a ground fault is detected. Fifthly, the absence of a specific requirement for GFCI protection for undersink pumps stems from their typical location and usage. Undersink pumps are generally installed away from direct water sources and are not considered to be appliances that are likely to come into contact with water. In addition, they are usually enclosed within a cabinet or housing that provides some degree of protection from water intrusion. Sixthly, it's important to emphasize that even though GFCI protection may not be strictly required for undersink pumps in all cases, it is always a good practice to consider installing it for added safety, especially if there is any possibility of water exposure. For example, if the pump is located in a damp environment or if there is a risk of leaks or spills, GFCI protection can provide an extra layer of protection against electrical shock. Seventhly, the decision of whether or not to install GFCI protection for an undersink pump should be based on a careful assessment of the specific circumstances and potential risks involved. Factors to consider include the location of the pump, the likelihood of water exposure, and the potential consequences of an electrical shock. Eighthly, local electrical codes and regulations may have specific requirements for GFCI protection that differ from the NEC. It is essential to consult these local codes to ensure compliance with all applicable regulations. Ninthly, it is recommended to consult with a qualified electrician to determine the best way to provide GFCI protection for water fountains and undersink pumps. An electrician can assess the specific situation, recommend the appropriate type of GFCI device, and ensure that the installation is done safely and in accordance with all applicable codes. Tenthly, GFCI protection is not a substitute for proper electrical safety practices. It is still important to avoid contact with water when using electrical appliances, to keep electrical cords and equipment in good condition, and to never overload electrical circuits. 11thly, regular testing of GFCI devices is recommended to ensure that they are functioning properly. Most GFCI receptacles have a test button that can be used to simulate a ground fault and verify that the device trips as expected. It is recommended to test GFCIs at least once a month. In addition to the general principles outlined above, there are some specific considerations that may apply to water fountains and undersink pumps. Firstly, water fountains may have internal electrical components that are particularly vulnerable to water damage. These components may include pumps, motors, and lighting fixtures. If these components are not properly sealed and protected, they could become a source of electrical shock if they come into contact with water. Secondly, undersink pumps are often used to pump water from remote locations such as sinks or dishwashers to a drain. This water may contain contaminants or debris that could damage the pump or its electrical components. Therefore, it is important to ensure that the pump is properly protected from these contaminants and that it is regularly inspected and maintained. Thirdly, the type of GFCI device used for water fountains and undersink pumps should be appropriate for the specific application. GFCI receptacles are typically used for general-purpose outlets, while GFCI circuit breakers are used to protect entire circuits. The choice of which type of GFCI device to use will depend on the wiring configuration and the desired level of protection. Fourthly, the installation of GFCI devices should be done by a qualified electrician. Improper installation can be dangerous and could result in electrical shock or fire. The electrician will ensure that the GFCI device is properly wired, grounded, and tested. Fifthly, the location of the GFCI device should be carefully considered. The GFCI device should be installed in a location where it is easily accessible for testing and maintenance. It should also be protected from moisture and physical damage. Sixthly, the wiring to the water fountain or undersink pump should be inspected to ensure that it is in good condition. Damaged or frayed wires can be a fire hazard and could also cause electrical shock. Seventhly, the grounding of the water fountain or undersink pump should be verified. Proper grounding is essential for protecting against electrical shock. The grounding wires should be securely connected to a grounded metal object, such as a metal water pipe or a grounded electrode. Eighthly, the electrical connections to the water fountain or undersink pump should be checked to ensure that they are tight and secure. Loose connections can cause overheating and could lead to a fire. Ninthly, the water fountain or undersink pump should be properly labeled to indicate that it is GFCI protected. This will help to prevent accidental disconnection of the GFCI device. Tenthly, the owner or user of the water fountain or undersink pump should be educated about the importance of GFCI protection and how to test the GFCI device. This will help to ensure that the GFCI device is properly maintained and that it will function properly in the event of a ground fault. In summary, GFCI protection is required for wall-mounted water fountains due to the presence of water and the potential for electrical shock. While GFCI protection may not be strictly required for undersink pumps in all cases, it is a good practice to consider installing it for added safety, especially if there is any possibility of water exposure. Consulting with a qualified electrician is recommended to ensure that the installation is done safely and in accordance with all applicable codes.